Okay, for this video, we're going to take the information from our previous video where we looked at throwing 30 dice and picking two numbers and eliminating them. So these were done on our previous video on how to get this data. And also in the previous video, we had zeros here. We're not going to be using the zeros. We're just going to be using the positive data. So this was one of the individual trials. I just picked at random, and this was our average on the 5 trials in the previous video. Now, it also turns out that we've supplied some information here where this is the average of over 1,000 trials, which you couldn't possibly be wanting to do on your own. So we have this information supplied. So what we're going to do in this video is find the exponential function of best fit for these. So the first thing we're going to have to do is to make some lists. So the first pairing is going to be with our roll numbers and with the individual trial. And we only want the non-zero entries. So this is going to be my list 1, but I'm only going to take it to 8. Okay, because we don't have anything to pair it with there, and your lists have to be the same size. So we're going to have 6 lists in all. Alright, well, I'm going to have to leave this here because of the glare. So the first thing we want to do is press Stat, and let's clear out 6 lists. Okay, and now let's go to list 1, scroll over, and I just want this from 0 to 8. Okay, now I'm going to scroll over to list 2, and I'm going to put the non-zero entries in there. And I like to check these by, I'm at the bottom now, let's scroll back up to the top. And let's check those entries. Okay, that's great. So what I'm going to do now is I'm going to find my exponential function of best fit for the individual trial. Alright, so I'm going to press Stat, I'm going to go over to Calc, and you scroll down until you get to exponential reg. It's actually quicker if you scroll up because it's right here. If you scroll down, it takes forever. Okay, now I want to get the exponential function of best fit with my list 1 and my list 2. So second 1, comma, second 2, and then press Enter. Okay, and also you got to make sure your diagnostics are turned on. If in your lab work they want to know these R squared and R's numbers, you press the second and the 0 button. That'll get you into the catalog, and you scroll all the way down to diagnostics on and press Enter, because we do want that to show for your lab. But the equation I'm going to get is y equals a, and we're going to take a to 3 decimal places, times b to the x, and we're going to take b to 3 decimal places. Okay, so that's my exponential of best fit. And my r, which we like to write it with a capital, if I take it to 3 places, that's 0.989, negative 0.989. And my r squared is, if I take it to 3 places, it's 0.978. Okay, now let's look at getting the exponential best fit for the 5 average. Okay, well, I'm going to need a pair list. So now I'm up to list 3 and list 4. And so list 3 is going to be my roll numbers, this time down until we get to 10, because I only want the non-negative ones. So that'll be my list 3, and my list 4 will be my non-negative entries here. Okay, so press Stat and press Edit. And I want to go to list 3 now, and I'm going to do these roll numbers down to the last non-negative ones, so they have to go to 10. Okay, and then I'm going to scroll over, and in list 4 I'm going to do my 5 average. Okay, so this is where we have to start being more careful because we got decimals involved. Okay, and then I like to scroll back up and just check. Make sure you check. Because one incorrect entry makes everything wrong. So now for my 5 trial average, I want to get the equation of best fit, so I'm going to have to use list 3 and list 4. So press Stat, go to Calc, scroll up until you get to Exponential Regression, and we want to use list 3 and list 4. Second 3, comma, second 4. Okay, so this time I'm going to have 34.204 times b to the x, and here my r is negative 0.993, and my r squared is 0.986. Okay, so the closer r gets to -1, the more accurate we're getting, and the closer r squared gets to +1, the more accurate we're getting here. Okay, and then my last exponential is for over 1,000, the average of that. So I'm going to have a pair of lists. It's going to be list 5 and 6, and I'm going to take all of these. So my list 5 will be all of the roll numbers, and this will be my list 6. Okay, so enter, and let's scroll over to list 5, and I want all of those 0 through 18. Okay, and then I'm going to scroll over to list 6 and enter these. Be very careful here. I just have to enter 20 there. Okay, and then we absolutely must make sure we check this. Okay, so go over to Calc, up here, and I need list 5 and 6. Okay, so for my mini average of over 1,000 trials, I'm going to have y equals a, which I'm going to take to 3 places, times b to 3 places, and my r here, if I take that to 3 places, that is now -1, and my r squared, if I take that to 3 places, that's +1. Okay, now simulations, you never in real life know the real answer, but here we do, And the answer in real life is the expected exponential equation is just flat 30 and then times 0.666, like going forever, to the power of x. So this is very, very close. So the more trials you do, the more accurate it gets. Okay, and the last thing that we want to talk about here is we want to put these in standard form. Now, what do we mean by standard form? Standard form is when you have y equals y naught, so your starting amount, times base e, and so to the power of k times t. So how do I change this, each of these, into a standard form? And so the process is you just put y naught equal to your a from your old calculation. You put k equal to the natural logarithm of your old b, and then you just put x, you put t equal to the x. Okay, so let's do that with each of these. Okay, so this will become y is equal to, and this was our a, so we're keeping that. And then we'll have e to the power of k, which is the natural logarithm of the number inside the parentheses here. And then we'll just substitute t for x. Okay, and then I want to do that to 3 places. So let's, I just want the natural logarithm of that. So negative 0.405. So that's my answer in standard form for the individual trial. Okay, so for the rest of these, I'll have e to the power of the ln of 0.634 times t, and ln of 0.634 taken to 3 places is negative 0.456. Put the t on it, and then that's my standardized form. And finally, this one's going to be, well, I'll start with that, and then e to the power of ln of 0.666 times t, and so my standardized form here, I'll take that to 3 places, and I'm going to get negative 0.406 and then times t. Okay, and we do have a decay because our exponent here is negative, so it is a decay formula. All right, and so that ends this video.